Hey guys, today we're going to go over the rules of exponents, and I know for a fact that you've done this before, but let's get these into our notebooks and do some practice problems so that you will have them available for reference when you need them. So the first rule we're going to talk about, the very first one, is if our exponent is a 1. So if we have, say, a variable, and our variable is x, and the exponent is 1, that just means that that's the same as saying x. X to the first power is just the same as saying x. So if we were going to look at an example of that, and let's say we had 7 to the first power is just equal to 7. Okay? If your exponent is a 1, what I would like you to do, and what I'm going to grade you on, the only way you will get full points, is if right underneath you write a sentence, and I'm not going to do it, but I want you to write a sentence. Maybe I'll give you a sentence starter, which is if the exponent is 1, then, and then tell me what the rule is. Then you just have the same thing. You just have the base, right? So over here, let's go over this a little bit. If I have x and a, and let's say n up here, let's just talk a little bit about what this means. The n is the exponent, right? My x is the base. Just so you know what I'm talking about when I use my academic language. And the a, this is my coefficient here, okay? Okay, so x is the base, n is the exponent, and a is my coefficient in this particular case. All right, so finish that sentence. If the exponent is 1, then what happens? What's the rule? Okay, for number 2, let's do an exponent of 0. If my exponent of 0, if I have 0 is my base, or if I have x is my base and 0 is my exponent, my answer is always going to be 1. This makes a lot of problems easy if you remember this rule. So here, again, write down the rule as a sentence. If the exponent is 0, then what happens? Okay, and over here, let's do an example. So if I have 7 to the 0 power, my answer is just 1. It doesn't matter. I could have 121 to the 0 power. My answer would still be 1. All right, so make sure you have that sentence there. I will not give you full credit for this if you do not have that sentence. All right, a third rule. Let's do a rule of multiplying. So if I have x to the, let's say, n power, well, let's make it m, x to the m power, and I multiply that by, and I'm going to go ahead and put it in parentheses. We're going to multiply using parentheses. I multiply that by x to the n power. Okay. What happens? What do I do with those exponents? And you guys, this only works if my base value is the same. So my base here is x, and my base here is x. It has to be that way. My base stays the same, and you add the exponent. So it's going to be x to the m, I don't know what it is, plus n. Okay? So if we have an example, let's say we have actual, let's just do it first with like 7 to the 5th power times, and this time I'll do multiplication as a dot, times 7 to the 3rd power. Okay, my base is the same, it's 7, then my answer is 7, my base stays the same, and I add 5 and 3, so my answer is actually 7 to the 8th power. And you can check this on the calculator by putting in 7 to the 5th times 7 to the 3rd, enter, get your answer, and then put in 7 to the 8th, enter, and then see if you get the same answer, and you should get the same answer, okay? But what does that look like if I just had x's and not 7's? It'd be the same thing. Like, let's say I have x to the 5th power, and I multiply that by x to the 3rd power. My answer would be, my base stays the same. It doesn't matter if it's 7. It doesn't matter if it's x. X to the 8th power. Okay, and I know you did this last year, so try to remember, and then write your sentence explaining what we just did. When you are multiplying, numbers that have the same base, what do you do with the exponents? So when you multiply numbers with the same base, what do you do with the exponents? It's just a sentence starter. You need to finish the sentence. Okay, when you multiply numbers with the same base, what happens? Okay, so that's multiplication. So what do we do next? We can do, oops, I don't want to do that. How do I get to the next page? Oops, don't want to do that. New note. Okay, so let's do division. So rules of exponents, just new. Next page, page 2. What are we on? 4 would be dividing. And you guys can keep going down. I just ran out of room. So if we have, let's say, x to the m power, this time divided by, and I'm going to write divided as a fraction, divided by x to the n power, okay? It's going to be just the opposite of what we were talking about over there. When you are multiplying, you add those together. When you're dividing, right, you subtract. So it shouldn't be any big surprise that we have x to the m minus n. Our base number stayed the same, and this only works if you have the same base value. Ours is x right now. Let's do it as a number. Like, let's do 7. So 7 to the 10th power divided by 7 to the 4th power is equal to, and since our base is the same, it stays the same. You can only do this if they have the same base. 7 to the 10 minus 4, which is the same as 7 to the 6th power. So again, you need to write that sentence down here. When you are dividing numbers that have the same base, finish that sentence. When you are dividing numbers that have the same base, what do you do with the exponents? Okay? And it's always, when you're subtracting, it's always the exponent on the numerator, and you subtract the exponent on the denominator. All right, what's next? How about negative exponents? Okay? So what if we have x to the negative n? What does that mean? That just means that it is on the denominator, that is 1 over x to the positive n. Okay, so if you want a positive number, you have 1 over x to the positive n. So if we had 7 to the negative 10th power, that is the same as 1 over 7 to the positive 10th power. It works with x's, just like, actually, go back up here. If this was x to the 7th divided by x to the 5th, that would be, I went back up to rule number 4 really quick to show you with variables. That would be x, 7 minus 5 is 2. That'd be x squared. Okay, and the reason that works up here is because if you have 7 x's at x to the 7th power, means I have x times x times x times 1, 2, 3, 4, 7 of those. And then on the denominator, I have 5. 1, 2, 3, 4, 5. Okay, so every time you have an x over another x, that's just a whole, it cancels out. So we can cancel out 5 of them, and then we just have x squared. That's where that x squared came from. Back to rule number 5. Sorry for that digression. Back to rule number 5. I wanted to show you, not only does it work with x's, like we could have x to the negative 5th is equal to 1 over x to the 5th. It is also, what if I had 1 over x to the negative 2 power? If I move it to the numerator, it becomes positive. Okay? So changing if it's on the numerator and the denominator just changes if it's a positive or negative exponent. That's all it's talking about here. So write that sentence. What do you know about negative exponents? You're going to have to pause this to write it down for yourself. We are almost there, you guys. Let's see. I'm going to change pages here. And for rule number 6, page 3, what if we are taking a power to a power, right? What if we have x to the n, in parentheses, we want to take that to the m power out there, okay? The rule is we multiply those two things together. We multiply. So x to the n times m. So if we have 6 cubed and we want to take that to the 4th power, it's going to be 6 to 3 times 4 is 12th power. It also works with x's. Let's say we have x to the 3rd power, and we want to take that to the 10th power. That's going to be x to the 30th power. All right, do not forget to write your sentence about what happens when you take a power to a power. And 2 more rules here, you guys. Let's do number 7 as if we have, let's say, x to the, let's see, x over y to the n power. That's going to be this. So this is the same as saying x to the n power over y to the n power. So what does this look like if we were using numbers? That would look like if you have 1/2 and you cube the whole 1/2. That means that it's the same as 1 cubed over 2 cubed, which 1 times 1 times 1 is just 1. 2 times 2 is 4, times 2 again is 8, is 1/8. That's the same as if you'd had 1 over 2 times 1 over 2 times 1 over 2. Okay, do not forget to write your sentence down here, or I will not give you full credit. And the very last rule that we're going to learn, you're in luck. That was the last rule. So make sure each of these 7 rules has a sentence written underneath it, or I will know you were not listening to this. You can go back and see what you need to put down there and try some of those problems from the practice sheet that I handed out.